right, so I'm Rudi Claes. I'm from Belgium, working for a Belgium-based consultancy firm and also teaching in the IC Institute. So I'm partly in the classroom, sharing experience, and partly in the field, gaining experience. And that's really fun to do, and also, in my opinion, the best way to go about. So, brief talk outline, a short history, because we're stressed for time, of composable architecture, then the link with Enterprise Design and EDGY, and the subject of this conference, and last but not least, how this has delivered a real proof of value in the utility sector. So, let's go. First, we need some line of thought, some imaging, so I'll be talking about concepts by showing some images. That works best in my mind, and hopefully it does in yours. So, think of composable architecture, software architecture, as a set of building blocks, Lego blocks, rather standardized, and we're going to ask a question about what is their ideal shape and what is their ideal size. So, short history. Think of this one. These are the Raptor SpaceX engines, getting the spaceship airborne and their payload into orbit. And the first thing you notice, they're rather similar, but also a bit different. So on the left-hand side, there is a Raptor 1, Raptor 2, Raptor 3. And what do you notice? Quick thoughts. Some optimization, yeah. Other. Sorry? Efficiency, yeah. Other things that come to mind? Simplification. So, reusability, yeah, great. So, as you can see, I guess adding more complexity is easy. Making a mess, no sweat. Huh? If you've got children, you know what I mean. On the other hand, getting complexity managed and simplified, evolved, that's hard. But it is possible in the, let's say, the manufacturing world. It should also be possible in the software world. So, some characteristics, they help out. So, what are they? Well, let's talk about managing complexity, allowing reusability, and enabling evolvability, things that were already mentioned. So, simple example of complexity, just follow the arrow from left to right, right to left. You see there is less complexity in Raptor 3. As such, you also see reusability taking place. So, for instance, the exhaust over here, and the cone, the tailpipe, so to speak, rather similar. And there are other parts, of course, that should be reused across the evolution of the product. Evolvability there is, of course, also key and mentioned. So, for instance, the fuel line, same function, but looks a bit different. There's an efficiency gain, of course, simpler design, but you see that basically these things are possible, all while you have to keep the engine, so to speak, running. And that's, of course, a challenge. So, let's see what it does for architecture. Managing complexity, reusability, and evolvability. So, usually when architects talk about architecture, they paint a picture. And usually they paint a picture of your application landscape, something like this. Pieces of the puzzle fitting nicely together. Some of the pieces we build ourselves. Nowadays, a lot of pieces get bought or rented, SaaS solutions and stuff alike. And if the pieces don't fit together, well, we've got some tools and craftsmanship and skills to make it happen, integration and stuff like this. Is this reality, my friends? No. Ask any IT guy or girl, and they will paint you another picture, something like this. Lots of moving part pieces and pieces of the puzzle, but it's far from a puzzle. It's kind of Mikado, held together under stress and keeping the lights on, and evolving this is a challenge. And that's where composability tries to kick in, we're going to try to align on those moving parts, getting them together, and in the end, target that end state of getting those pieces aligned. That's the idea. So, key questions. What is the shape of these things? What is the size of these things? Noting that software is a dynamic system. What does it mean? Well, it has a lot to do with how the shape and size should be defined. Best way to explain this, or the fastest way, is through NST, Normalized Systems Theory. We've got a lot of experience in developing software and software architecture, best practices, design patterns, and also backed up by academic research. One of these things is NST, and it states basically you see dynamic systems happening everywhere. In the real world, biological, mechanical, and also one of the most quoted examples is the collapse of the Tacoma Narrows Bridge in 1940. There is a small movie on YouTube. You see the bridge starting to wobble. It only gets worse, and at the end, it really collapses. The reason why, it was a dynamic system, and it couldn't handle the fact that any kind of dynamic system is subject to forces and has to cope with it. We call this the damping effect. And basically what happened is that the force of the wind was input for that system, and the bridge wasn't capable of handling that. It only got worse. So there was no stabilizer. And the idea is that composable architecture, like any dynamic system under control, should have or should safeguard dynamic stability. Stability is that A factor. If it's 0, no stabilizer, you're in trouble. So basically, another example is something like this. Sometimes you do want to realize instability. Left-hand side, going nuclear, that's the idea. On the right-hand side, going nuclear is, of course, not the idea. The idea is there to keep the chain reaction under control. So there is a way, in reality, that you can go from stability to controlled instability and to stability again. That's a dynamic system. Now, does it apply to software? According to NST, it does. So basically, they did a lot of research and stated, okay, what is then the input for our software system or our software architecture, the output, and how can we add a stabilizer, the damper? So, and I guess you know the answer to that one. X is requirements, new and changing requirements all the time. Y is the output, software modules, new modules, changing solutions. And A is a way to get that under control. So the change ripples, the changes of, and the combinations of those changes need to be as minimal as possible. That's the idea over there. And it can happen by applying some principles, things we already know, best practice and design patterns, things that were coined by and backed up by academic research. So basically, what are those things? And as such, they should also be applicable to those composable units, defining their shape, optimizing their size. So they're here listed up. I'm not going to discuss them in detail. So they might be recognizable. Who has something to do with software? Okay, who knows the terms low coupling, high cohesion? Okay, a bit redefined with those things like data version transparency, action version transparency, separation of states and concerns. That gets you into a damping effect, getting the thing and keeping it under control. So shape rather okay. But the second observation was composable architecture emerged in times of rapid adaptation. The fastest way to explain this is through Martek's law that states technology changes exponentially and organizations adapt logarithmically. So whatever you do, you're behind. The only thing you can do, it was mentioned before in the Morning sessions is, okay, let's make smart choices. And smart choice could be boosting up the absorption curve a bit, so getting a bit more agile, incubators, research and design, innovation, toying around with some stuff, injecting it into organization, that's a bit harder. Becomes even harder if you're going about revolutionary, a reset, digital transformation, and digital is the easy part. The transformation, as mentioned before, that's the hard part. So, and it can even get worse. This fellow popped along, COVID-19, and that led to this one, a cataclysmic event. As such, we had to change super fast, lightning fast. There's a famous example in Belgium, shoe brand, that had to change from classic selling shoes through shops towards full online e-commerce. And after the period, they said, well, in 2 months' time, we evolved what we normally had as an ambition in 3 to 5 years. We were forced to do so. So those huge change ripples are there. And well, if our architecture looks like this, the Mikado, that's a bit like the tidal wave that hit Fukushima in Japan. Very limited time to react. Let's say that e-commerce tsunami that took place. That's where composable architecture emerged as a solution to more or less make that huge change ripple, that tsunami, and in some way, in the time that we had, to adapt for it. So if that input is so huge, we need extra stabilization. So as such, observations like Gardner stated, okay, some organizations were capable of mitigating this and coming out for the better. Some outsourced it, some didn't make it, weren't able to cope. But the ones who did, those were the ones that were able to shape those building blocks according to some principles. You see them over here. So it's about modularity, autonomy, orchestration, and discoverability. And they coin also some flavors of those packaged business capabilities. So it's a business capability being packaged by some assets. You see them over here. So they had a fairly good idea about the shape. Size was something else. So a small example to illustrate this. They didn't get further than this. Simple composition from some building blocks gets you into housing capacity planning and student education planning, depending on how you assemble those building blocks, those composable units. But then again, too large might not be a good idea, too small neither, so they stated, let's see and observe what happens, and we'll conclude on the result. So shape, okay, size, something else. At the same time, banking, there was an initiative by the BIAN, Banking Industry Architecture Network, that after 10 iterations coined a reference framework that was able to describe any bank on the planet. Merchant bank, commercial bank, small bank, large bank. Their idea after 10 iterations was, we have functional building blocks that are able to describe it via service domains, an elemental or atomic functional building block that can be service-enabled as discrete and unique business responsibility. So there, business again, service-enabled, functionality, and also well understood by business. A bank guarantee, for example, is something we all understand. If you want to buy something expensive, like over here, a Ferrari, for instance, they will ask you for a bank guarantee. We know what it is, we can coin it, and we can use it as a functional building block, and also service enable it, also in a technical sense that they have some reference APIs, the preferred way nowadays to do some integration, to see how these things could work if you would API enable them. So shape, rather okay, size, rather okay, and that combination that of course next to e-commerce, that in banking there is a lot of composability going on nowadays. In two flavors, you've got it as a platform, so the fintechs of this world can play nicely with all these others, and the bankings themselves, so they can also provide services to themselves and also to non-banking businesses, like PSD2 or PSD3. European regulation forces banks to open up their back-end systems to other non-banking institutions like a Kinepolis for movies or ticketing or whatever kind of organization that is in need for banking operations. And that's, let's say, by law now regulated. And of course, very interesting to do in this fashion. All right, interesting, but you could say it, well, really dark blue in EDGY terms. What's the link with enterprise design and EDGY then? So let's see. So composable architecture is the outcome of applying composability. So you can ask some questions at various levels. For instance, enterprise architecture, how to define future state with composability in mind. Solution architecture, how to select those building blocks to make up your solutions and to do some trade-offs. And towards implementation, how to introduce, implement, and evolve such a thing. At the same time, and now it becomes interesting, customer journeys, how to optimize user experience with composability in mind. And towards those PBCs, capabilities, technology, and packaging those together in a business fashion, how to evolve from current state to platforms and platform-based PBCs. All interesting questions. I would need about 2 days' time to explain this in a masterclass, but let's speed it up and see what happens on a 3x3. There are 5 solutions for this. Defining customer journeys, and here's the link with enterprise design. Shaping PBCs based on those buy and service domains, also with the help of EDGY. Those other 3 are more in the blue region, so just for your information, EA principles, quality attributes, composable reference architecture frameworks like MAG or cell-based, whatever. So they will help the implementation. How does it work? In any case, and any architect can validate on this one, if you want something done, there has to be some intent. Intentionality is key to success. So hence, from enterprise architecture, through solution architecture, towards the actual implementation, there needs to be some composability injected. So from solution to technicality, inform people why they are in need to build the solution like you have to devise it. Inform them why and what's the role of composability. Same deal between enterprise and solution architecture. Guide your solution architects and solution architectures by offering them guidance and using them and allowing them to use composability as a parameter and balancing it with all those other things, because over there, the right solution is a balance of choices. Composability should be one of them. And of course, last but not least, high strategic level, directionality, future state. Define what composability means for your organization. Usually it's something to do with application, integration, and data. So these are these 3. The fun starts now. So now it becomes an interesting part of the talk. And I see Milan smiling now. So EDGY. So what's the link? So basically this is the link. Stepping out the comfort zone as an architect, out of the blue zone into the red zone and across back again. Thanks. Key question, what does potentially have the most impact on composability? Quick answer from the room. In the blue? In the red? Capability, okay. Both, okay. Actually, as it happens, it's this one, the task. Changing tasks in composability, going from selling shoes in a shop or selling shoes online and using the shop as a distribution hub, that's really different in tasks. Those were the huge change ripples. So composability is key In identifying those tasks, there are top and important. If you want to know more, certification course from Intersection, warmly recommended, dives into these details. So I was happy to reuse these things. So as such, we can and should reuse it like this. So customer journeys with the tasks being qualified, services composed with those composable units, those Lego bricks, service domains aligning on functionality. That's where you enter into, okay, a composable architecture in edgy fashion. Let's see how it worked out in reality, because that's the real check. So, utility, really quick, it's European regulation, so the E from EPRS is European. Works like this, you've got the ones that produce the energy, you've got those that transport the energy, and of course, over here, the ones that consume the energy. Specific case are the prosumers, the producers, consumers, the ones having solar panels and digital meters. And that has change ripples on the role of a DSO, which was rather back-end batch-oriented, now is really front-end, really proactive. So they came to us with some concrete questions. They already were convinced of we need to check out composable architecture. We learned some lessons from COVID. So how to get started with composable architecture was a question. How to identify platform-ready PBCs and how to document and model them. The answers, some root cause analysis, some reframing. So answer on question 1 was, well, actually we want to avoid silos and tie dependency between process and applications. So basically, on the left-hand side, they were over here. After some reframing, we stated, well, you should be over there. And as such, involve the architects in the team that they need to cover the axis from the blue to the red and back again and see what that does on your organization and actually your purpose. So, question number 2, they had, well, okay, sounds good, but how do we bridge business architecture and the techie guys, the other architectural roles? Usually it's something like this. So business architecture focuses on process capability, organization, maybe a bit more. Technical architecture is heavily into the assets, the bits and the bytes, and they need to talk to each other and understand each other. So there is a communication cost to be paid inside the blue area itself that we're sometimes aware of, sometimes not. So the idea over there was, okay, let's do some alignment, some workshops, some interactive sessions, and to be in the clear what it means to do something like this. Then, of course, modeling, documentation. They were using an Archimate subset, rather technical language, but it works well for architects, but for other roles it does less. Modeling tool, they were using Sparks. The idea that we had, okay, let's align on that axis, assets, capability, product, task, and see what happens if we plot that onto their way of documentation. This is how it looks like in EDGY. So you've got 2 service domains, the market communication part, the smart metering part. They're distinct users and actors, and you can see over here, they have different top tasks in mind. For the prosumer, it's about optimizing energy consumption, and it's about minimizing the monthly advance. Electric generators are in charge of nominations, let's say energy forecasting, and they are focused on yearly invoicing. As such, they are using the same thing, metering, the volumes of energy being consumed, but in a rather different fashion. So it would be a really bad idea to combine these things in one large monolithic thing. It would be an interesting idea to split it up and to make it a bit more composable. By using the assets, the capability, that's the packaging, serves enable them with the product service. You can then target your distinctive actors and their top and important tasks. And as such, it also works with those PBC qualifications from Gartner. So service domain, broken down into distinct PBCs. An application, of course, the key, the metering, analytics, digital twin, the smart meter, and the prosumer ingestion as a process. And as such, mapping that with the help of the ArchiMate EDGY mapper, we were able to do that into Enterprise Architect. Triggered me a bit about, we can do a bit more, so I created a free plugin for Sparks that we can do some native EDGY modeling with elements, with connectors, stereotypes, and also an interesting fact that over there you can start combining modeling languages, so it's fairly easy to click through on a process and open up a BPMN, for example. So it's free, and if you're interested, contact me and I'll let you know. So that's it. So the short history, link with Enterprise Design and EDGY, and how this thing delivered some value. Thank you.
Wonderful, thank you so much. And Milan was all giddy when he saw the evolution of the of the application. That's a very good sign. Comments and questions for our friend?
We're just before the break, so that's really dangerous. Did it make sense? Composable architecture then 30 minutes ago? Then that's okay. So if you've got questions now, during the break, tomorrow, or later, just contact me. If you're interested in that Sparks plugin, also.
I have a question, yeah? We say that enterprises are socio-technical systems, yeah? There are people and there are IT and other engineering technical stuff. And this composability, componentization is a concept that is very prevalent in the engineering world. Yeah? Whenever I bring this idea to the world of organizational design, people are focusing more on the social, human side of companies. I'm being perceived as a bit nerdy engineer. You don't understand people. So can we really see and put people inside of a component? They don't really like it. I mean, they're people. Yeah, you can't engineer them. What do we answer them? I need the answer.
Well, my answer, maybe it's not the answer, but let's quickly leave back to this one. So you asked, well, I tend to ask questions. Also yesterday on the advanced workshop, my approach is the people approach. I ask questions, or the philosophical way, asking questions to get answers. I tend to ask people, what do you want to achieve? And a quick answer from these guys will get you into something really different. That if you talk to prosumers, they will have very different things in mind than the EGs, for instance. And so the social engineering you apply over here then can be kicked back to the hard bits and bytes stuff where the developers are, and they need to understand what these guys need, the requirements, quote unquote, so to speak. But hard requirements, they find themselves over here in the actual real world with real people having real needs. And that's, in my view, the important part of the story. That composable architecture is a lot more about the people and the process and almost nothing about the actual tooling, so to speak. Of course, technology is important. You need PaaS and SaaS solutions, those pluggable components, but there, let's say, the side dish. The main course, in my view, is something like this. Yes? They're over here, so no, they're separate and deliberately separate. So that's the analytics VBC over here. So in the example, that's the actual fuel, prosumer metering. The engine crunching those numbers is the prosumer insights over here. Separate from application, because one of those composable architecture principles at EA is data independence. It's so hard to get actual data out of systems. It's even harder to apply them in the right context, turning into information. That's what, let's say, the proverbial 80 and even more % of organizations struggle with today. By design, separating them at this level helps out. It's not a silver bullet. It's a prerequisite, in my opinion, but it gets better if you design it like this, so to speak, at enterprise design level. Let's say intentionally. The intent should be there at the beginning. Integration, same deal, so same story. Make sense? Okay.
Well, thank you so much for sharing your perspective. We really appreciate it. Another warm round of applause.